All right, so in this demonstration, we will initiate ARP poisoning into this network. For this, we will use Cain to demonstrate how we can perform ARP poisoning. Now, you may still think that ARP poisoning is a hard test to do, but I'll show you actually how it can be very easy with Cain. Now, the first thing we have to do is go to Sniffer and then scan for the hosts, while Note will tell you that the sniffer has to be active in order to scan for all the hosts in this particular network. We can now turn on the sniffer here, stop sniffer, and then we can scan the network. Okay, we can now specify a range of private IP addresses for all the addresses really on this subnet, and we can see devices start to appear. Anyway, you can initiate all the tests, but it doesn't really matter for now because we can get them easily with this one simple test. A few cool things with Cain: you can right-click any device, which we will use in this demonstration, and we can scan or resolve the host name. So here's our gateway. Looks like it's a Cisco device. It will not resolve anything on the gateway right now. It will only work for computers. We have gathered all the devices connected to this network. So now it's time to navigate. We will go down and go to ARP, but before starting the ARP poisoning, we have to specify which devices we need to poison. So click the plus button here and specify the first device and the second device. And as you can imagine, we can poison between the computers. We can poison a computer-to-computer communication or a computer-to-gateway communication. So this is what we are going to do. Click OK, and then hit the start button. You see the yellow start-stop APR? That means it's poisoning now. In order for that to work fine, you see 0 packets. The victim computer has to initiate some requests. So I'm going to go navigate quickly to the next virtual machine and initiate some requests. I'm going to go to Google, and then I'm going to go back here and wait for that poison. We see that it's half poisoning. Full routing indicates that the host 17 is directed to our computer here, and then from our computer to its destination through the gateway. Now we see the MAC address used for each one, but before continuing on with what else we can do with ARP poisoning using Cain, I want to go to Wireshark and start to capture. So I'm going to wait a little bit and then filter to see just the ARP messages on this network. We choose ARP in the filter. We wait for some ARP messages to appear. And we should be aware that the filtering in Wireshark is not always as easy as it looks. There is a help menu for which filters you can use, so that's good news. So let's start checking out what we have here. Let's see, 192.168.5.222. Looks like that is the gateway at this MAC address, and 192.168.5.17, which is our victim machine at the same MAC address. Now this is what ARP poisoning is. We tell our victims and our target that this IP address is on our MAC address. So this is actually the MAC address related to this exact machine. We're telling, in essence, both of them that they are on our MAC address. This is how ARP poisoning works. If we analyze and take a deep look here on this traffic, we will notice that for all the communication, the destination is the gateway or the victim machine and is redirected then through my computer from this exact virtual machine right here. Let's go ahead and minimize Wireshark. We can go back to Cain. Now, check out what we're capturing. We are not just redirecting the traffic, but we are actually capturing certificates. So certificates used will be captured. Google issued an encryption certificate. So let's navigate back to Cain. We'll see here that we have captured the login live certificate. So let's go down to ARP HTTPS. We'll see here all the HTTPS sessions that were initiated. Now, just to let you know, if I have initiated any HTTP session, I will see it here as well. We can also check out RDP, FTPS, POP3s, IMAPs, LDAPs, and so on. New protocols are being captured with Cain, and with this captured Wireshark, I'm sniffing and capturing all the traffic. So if the victim has logged into Hotmail or any other website or sent an email, we will capture that here. If he's using Outlook for email, we will capture Outlook sessions here. If he is using POPs or IMAPs, we will capture that right here as well. You see the point. Mainly we are capturing all kinds of traffic being initiated by our filter. This is mainly what ARP poisoning does. All right, so let's summarize what we've done here. First and foremost, we have poisoned the communication between a victim and the gateway. After that, we captured all the sessions initiated by that victim. We took it even further. We captured certificates used for encryption and authentication as well, if there are any. and we captured all the HTTPS sessions.
Look at this slide. Since entries in the ARP cache timeout, the attacker must keep sending spoofed ARP, gratuitous ARP packets on a recurring basis. Notice how the hacker keeps sending ARP messages to bind all the IP addresses to the same MAC.
That's right. MAC spoofing is a technique for changing a factory-assigned media access control, or MAC, address of a network interface on a networked device. The MAC address is hard-coded on a network interface controller, or NIC, and cannot be changed. However, there are tools out there which can make an operating system believe that the NIC has the MAC address of a user's choosing. Therein lies the rub. The process of masking a MAC address is known as MAC spoofing. Now, essentially, MAC spoofing entails changing a computer's identity for any reason, and oddly enough, it's relatively easy.
Correct. DNS spoofing, or DNS cache poisoning, is a computer hacking attack whereby data is introduced into a domain name system, DNS, name server's cache database, causing the name server to return an incorrect IP address, diverting traffic to another computer, often the attacker's computer.
That's right.
And in computer networking, a source routing allows a sender of a packet to partially or completely specify the route the packet takes through the network. In contrast, in non-source routing protocols, routers in the network determine the path based on the packet's destination.
Yeah, source routing can be used for hacking purposes by allowing a hacker to get data to a machine that would not normally be reachable. Some machines are on private internet addresses such as 192.168.1.1, and they are not normally accessible from the internet. If there is a machine on a private network that performs routing and traffic may be routed through between two other networks. It may be possible for an attacker to specify their data to go through the actual machine on the private network. The attacker may also fool the machine on the private network into believing it is some other computer using IP spoofing. So many different ways. And the best way to prevent this attack is to configure the router on the private network to ignore source routed packets.
Routing can also be compromised by the injection of false route information and by the modification or removal of legitimate route information. Route information can be injected or altered by many means, ranging from the insertion of individual false route updates to the installation of bogus routers into the routing infrastructure. Potential denial of service conditions may result from intentional loops or black holes for particular destinations. Attackers may also attempt to redirect traffic along insecure paths to intercept and modified users' data, or simply to circumvent security controls. Professionals recommend that you navigate to the link below and read more about routing infrastructure to learn how it works and how to secure it.
Right.
Very important.
Yep. And there are certain cases where ICMP packets can be used to attack a network. Although this type of problem is really not common today, there are situations where such problems do happen, so they're worth looking at. This is the case with ICMP redirect or ICMP type 5 packet. ICMP redirects are used by routers to specify better routing paths out of one network based on the host choice. So basically it affects the way packets are routed to their destinations across the board. Now, through ICMP redirects, a host can find out which networks can be accessed from within the local network and which are the routers to be used for each such network. Now, the security problem here comes from the fact that ICMP packets, including ICMP redirect, well, they're extremely easy to fake. And obviously, basically, it would be rather easy for an attacker to forge ICMP redirect packets.
The attacker can then basically alter your host's routing tables and drive traffic toward external hosts on a path of his or her choice. The new path is kept active by the router for 10 minutes. Due to this fact and the security risks involved in such scenario, it is still a recommended practice to disable ICMP redirect messages. Ignore them from all public interfaces.
Yeah, it's a good way to put it. And a rogue DHCP server is a DHCP server on a network which is not under the administrative control of the network staff. It's on its own. It's a network device such as a modem or a router connected to the network by a user who may be either unaware of the consequences of their actions or maybe knowingly using it for network attacks such as man-in-the-middle, something we've talked about. Now, some kind of computer viruses or malicious software have been found to set up a rogue DHCP, especially for those classified in the rootkit category.